start ಮಾಡಿ.
So today the computer organizations second class, the basic operational concept, the fundamental introduction part we discussed in the previous class. So now in this class we will discuss in detail with diagram the working conditions of the between the processor and memory. That is called the connection between the memory and processor. So here the major concept is the interaction between the processor and memory, because these two are the major role when performing any operation in the computer system. Not only for input device and output device, which is the major role for providing the service to the computer and display the result. In addition, the internal performance of the computer system depends on the processor. So here the overall structure of the processor. This processor consists of variety of hardware devices which is helpful for performing the operation, as well as performing the operation of the processor, which is most important. The role is the memory. The memory, I told in the previous class also, the memory is the most important concept in the computer systems. The memory is divided into two parts, primary and secondary. But here we are taking the role the primary memory, that is RAM. Because any performing operation, that is the assigned data to execute, that depends on the speed of the memory. Now come to the point, the connection between the memory and processor. So here MAR, MDR, control unit, arithmetic logical unit, program counter and general purpose resistor, together it resides in the processor. Whereas memory, so this memory is connected with the processor through the MAR, MDR control via buses. That is called as an address bus, control bus and data bus. Come to the point, when the user sending the any information or data in the form of input, and major concept is memory will accept first. That is nothing but the primary memory through the communication line. Once the memory receives the data, the input data, and this memory will send or particularly one location, it will store the data. Then with the help of resistor, so these are the resistors are there in the processor. Memory address register, MAR, MDR, memory data register. Okay, so these two are the major important role for accessing the data from the memory to the processor and storing the data from processor to the memory. So that's why we talk these two are the standard register, load and store. Load and store. The load register is a register where it loads the data from the memory to the processor. Loading LDA registers we are using, LDA and STD. So these are the standard registers. So memory, which stores the data or instructions, are sending from memory to the processor with the help of LDA register with the address registers. That is the address registers. Because the 1 GB, 2 GB, different locations are there in the memory in the form of cells. Okay, where row and column, where it intersects, which point is called as a cell. That cell resides the data. So here, particular data where it resides in the memory, processor don't know. So memory address register will help to identify the address where data or instructions are stored in the memory. So with the help of memory address register, it will access the data into the processor. Then Program counter resistor (PC). The program counter resistor is a register which holds the address next instructions to be executed. And what happens in the processor? It execute continuously data. Fetch, decode, execute, write back. Means continue. Processor is busy to work performing the operations continuously. We know that computer is the fastest as compared to the other machines. So why? Because it continually executes the instructions one by one. So how it is possible means this program counter register, okay? When currently processor will execute any one instructions, this program counter register holds one more instruction which is next to be executed continuously without any idle in between the even though in single 1 millisecond. Continuously processor will execute the instructions. So here program counter register will hold these instructions and immediately after execution of the processor, for example, instruction 1 is there, instructions 2, instructions 3, or you may consider data 1, data 2, data 3. Data 1 processor is executing, then data 2, data 3 had this program counter. Once data 1 is executes the processor, immediately data 2 will be loaded with the help of program counter registers. Next, come to the point, what is the role of general purpose registers? So here R0, R1, R2, R3, R4 up to Rn minus 1 means n number of general purpose registers we are using in the processor. What is the role of these registers? As we know that the memory is divided into number of different categories, primary, secondary. In addition, cache memory, flash memory, and resistor. Resistor is a small amount of memory, single bit storing capacity, and it is the fastest memory as compared to other memory. So resistor is a single bit storing capacity and it is very nearer to the processor. That's why it is a very fast resistor. So here R0, R1, up to R, these are the general purpose resistors we can say. N number of general purpose resistors which are helpful for performing the operations when the processor requires additional support to execute the instructions. So that time, for example, there is a n plus n addition numbers are there. Okay, so that time it is required the memory more. For example, that time these temporary registers are using the processors. Time being for holding the data or informations. So these registers are using. Come to the point arithmetic and logical unit. ALU. ALU, as you know that ALU means arithmetic and logical unit. So the processor perform any arithmetic operations and logical operations. So arithmetic and logical unit we are using. For example, addition, multiplication, division, subtraction, arithmetic, as well as logical. So logical gates I think you studied, that is and, or, not, okay, and or not. These are the basic gates. So different logic gates are there. So these operations are performing this arithmetic and logical unit. So these are the fundamental basic concept for performing any single instructions to be executed by the processor. These arithmetic and logical unit is the major role to perform to give the correct 100% result to the processor. So here arithmetic and logical unit, whenever it is required, then only it will provide the service to the processor. Come to the point control unit. So this control unit controls the not only the memory as well as the local all registers also control this control unit. Because sometimes what happens, the processor is busy for performing the operations continuously. So that time, this side what happens, it may be chances of, because every data or instruction should be transferred to the processor, it is required the communication bus, that is called as a system bus. So the system bus which consists of data bus, address bus, and control bus. To perform those operations, sometimes what happens, it may be chances of collision. collision will be occurring. To control, this control unit will be manage all the resistors efficiency and performance, and schedule also most important. Which time period, which resistors are active? What about the other resistors are in the idle mode? So all the informations are maintained in the control unit. Because I told you n number of resistors are there. R naught to Rn minus 1. So these n number of resistors, very chances are only few resistors are active, performing the executions. What about the remaining? Remaining are in the idle. So control unit will identify how many resistors are in the active to perform the operation, which is helpful for the central processing unit, that is processor. What about the remaining? So all bit by bit, all the informations are maintained in this control unit. What about the MAR and MDR? In which time period address registers are accessing the data schedule? After execution of the processor, the data will be resides in the memory, or it may be chances of it will be displayed on the display unit. That is, we call it as a monitor. Okay. So time period is also maintained this control unit. So arithmetic and logical unit, control unit. Next come to the point MDR. So this MDR is the memory data registers. Processor accept the data through the memory, execute the data with the help of registers and arithmetic and logical unit. After result is displayed, what processor should do? It may be chances of processor will not hold longer time period for the result. It is having some other work. Hence, next instructions to be executed. Immediately it will be sent to those processor execution data to the memory data register. Then this memory data register will not hold here the instructions, whatever executed result. Immediately it will transfer to the main memory. Remember, processor will not hold longer time period the resultant data. Immediately it will transfer to the memory with the help of memory data registers. Because the processor is executing the next instructions with the help of program counter. Okay? And one more resistor is there. That is called as an IR, instruction register. Instruction register means identifying which instructions to be executed, whether it is addition, multiplication, division, or it may be only transferring data from one register to another register. Move data is there. These are the different microprocessor instructions are there. The further next semester we will study these microprocessor and microcontroller subject related. So these different registers are different rules are there. Okay. So after resultant getting the memory data register will send the information data to the memory. Remember, first basic step for after processor executing the instructions. Getting the result, send. Where it should be sent? That is the most important. Data is there, memory is there. In the memory, in which location? It is having, for example, 2 GB RAM. In the RAM, where? Because it is having number of sectors are there in the memory space. Particular location is required. That is nothing but address. Why it is required address means in the future, though resultant data to access to the processor for execution of the next some other task purpose, we require the address. For example, you are storing one file in the computer system. Your computer system having more than 512 GB data, 512 GB memory. But where you are storing? In C drive, D drive, E drive, F drive, in the Z drive, whatever it may be. Particular one drive you are selecting and particular one folder you are selecting, and then you are storing that file. Why? You can store anywhere, no? But you are making the location. That is nothing but an address where your data is storing. Why mentioning those address? Because in future, in further, some those file you require easy to access if you know the address. So same thing here also. When your resultant data is storing in the main memory is not a permanent. But time being you are storing here. Later what happens? I will tell you. Data will be sent to here. Okay. Then main memory rule is what? Up to computer system is active, that much of time memory is active, main memory. It may be chances of from this main memory to the monitor, means display unit. The user should know whether the result is right or wrong to justify. One option. Second option is if you want, you have to save it wait in storage device. That is called as a secondary storage device. Wrong. Secondary storage device, or you may call it as a hard disk also. So main memory to the secondary memory. It is possible because data will be stored permanently here. Here also memory location is required because huge amount of storage capacity is there. It may be 1 GB, 2 GB or 4 GB, but it may be access of 512 GB, 1 terabyte, 2 terabyte, depends on the computer system. So this is the overall basic concept of connection between memory and processor. Okay. Any doubts regarding these diagram and working condition between the processor and memory? You can ask the group. Okay. Any doubts is there? You can ask. Next, it is a functional unit. So here in this functional unit is a parts of the computer systems. Again, it is a similar concept. Okay, little bit different diagram is there. Okay, but parts are same. The overall computer internal hardware devices. So in this functional units are made with a clustering. Clustering is nothing but a partitions. Together we can say it is a CPU. Together devices we can say it is a computer system. What is the meaning of computer? Computer is electronic devices. Lot of different electronic devices are there. We can't say any one single chip. We cannot say it is a computer. Collection of devices, electronic devices, to perform the operations to get the result. That is we call it as a computer system. So here also, the functional units. In the functional units, it contains the hardware devices. What are the hardware devices? You know that hardware devices are the keyboard, monitor, mouse, etc., etc., printer, scanner. We can say it is a hardware devices. Next, come to the point. How it is made the different categories. For example, here input is there. Question is this: here input and here also output. In the same way, the output is there. Output and together we can say it is an IO devices. Okay, IO devices, input and output. These two are the major external devices to provide the services, especially for input device, is provide the services to the processor input device. But how it is possible? How this input device provides the services to the processor means through the memory. Memory which consists of primary and secondary, but without memory it is a dummy computer system. One thing I will tell you. No use. Because it is required on platform to stand the data or instructions. It requires some base. Particular on single bit of instructions is to execute it is required a resistor. What is a resistor? Resistor is also memory. Means a single bit of instructions to be executed, it is required a memory. Without memory, no use of the computer system. So memory is the major role. Either primary or secondary. Okay. So input device sending the data to the processor through the memory only. It is possible. One thing I will tell you. Then come to the part in the processor. I think you already know that this is arithmetic and logical unit and control unit. So these two are the major role in the processor, and lot of different registers are there. I have not mentioned here. Previous diagrams also you seen that data register, address register, means general purpose registers are there. Instruction register, program counter, MAR, MBR. Lot of different registers are there. That is in detail in the processor unit. And input provide the services to the processor through the memory. That is one concept. That is a one step in this basic functional unit. Come to the point next. Processor will execute the result or execute the instructions data. Again, it will send to the memory. It may be stored data permanently in the secondary storage device, or it may be what happens, or it may be transferred to the output device. So this is the output device. So this output device through it will send to the monitor or display unit. So that's why these two are the major role. External devices, input device and output device are the major role. Any doubts are there? You can ask.